So for the first problem here, you're asked to give the initial value, the continuous growth rate, the annual growth rate, and growth factor, sorry, and the annual growth rate for each one of these functions. So the initial value is the easiest, right? It's just the number you're multiplying by. So 1450 is the initial value. Your continuous growth rate is k. That's the coefficient of t in the exponent if it's a base e exponential function. So that's 0.72. This would be your continuous growth rate. And then your growth factor is e to that power, right? It's just that number. And this is, if you do it in calculator, 2.0544. And so then r is b minus 1. So this is 2.0544 minus 1, which is, so this is your 1.0544. So this is your growth factor. This is your growth rate. And so this corresponds to 100.0544% if you want to write it in a percentage. So it's right, it's just going really quick. Okay. Second one. Yeah, okay. So this is what, 10,000? So your initial value is 10,000. Initial value. Your continuous growth rate is negative 0.48. So this is your continuous growth rate. B is that to, right, it's that e to the k. So this is e to the negative 0.048 is 0.6187. Good enough. That's your factor. R is b minus 1, so 0.6187 minus 1. That gives you negative 0.3812, or you could write this as negative 38.12 as a percentage. You would have to have the negative there, though, because it's not clear if you're interpreting this, right? You'd have to have the negative sign. Okay, moving on. Under question 2, so a dumpster starts with 5 pounds. Write a formula which represents the amount of garbage 2 days after, given each one of these different scenarios. So if it increases by 3 pounds per day, well, this is linear, right? If it's increasing by an amount and it's not a rate, it has to be a linear function. And you initially have 5, and this is the slope. So this is a classic chapter 2 problem, 5 plus 3t. Here it increases by 3% per day. So your growth rate is 3%. It's positive because it's increasing by that amount. And so this is 0.03. And so B is 1 plus R, which is 1.03. And that's what you use for your formula. So this is the initial value, which is 5, times 1.03 to the power of t. You have to, even though you're given the growth rate, because that's what we want to work with, you still have to convert this to b, right? That's not optional. And then finally, it increases at a continuous rate of 3%. If you see continuous, that's implying that k is 3%. So then this is 0.03. And it's increasing, so it's positive, right? So f of t is the initial value, 5, times e kt. You don't have to find the growth factor, right? That wouldn't even do you any good here. So this would be your representation. Okay, lastly, yeah, I'll do question 3. So you have 1 liter liquid, so that's your initial value. It evaporates at the continuous rate of 2.3%. So we know that this function has 1 liter initially, so it's 1. And the continuous rate is 2.3%. So k is 2.3%, which is 0.023. And it's evaporating, so it's leaving. So it's negative. So it's negative. Be a negative amount. So it's e to the power of negative 0.023 t. What is the daily decay rate? So this is asking for r, right? So if we have b, the growth factor, is negative 0.023, then this is we can do this number. This is e to negative 0.023, and this should be less than 1, right? And it is 0.9802. So your growth factor, your growth rate, your decay rate here is b minus 1, and that minus 1 is negative 0.0227. So this is negative, which again, that makes sense because it's a decreasing function. And so this is your growth, this is your decay rate, or you could write this as negative 2.27%. That's fine. How much remains after 5 days? This is evaluating the function at 5, and you could use this, or you could use this as if you put that into the formula, but we already have the formula from part A, so that makes sense to use here. So this is negative 0.023 times 5, and that number, negative 0.023 times 5, this whole thing is 0.8914. And this being less than 1 makes sense because you started with 1 and it's decreasing, so it should have ended up less than 1. And this would have units of liters.